Hi everyone. In this video, we are going to do probability. There are three videos for probability. This is the first one. This one is called fundamental counting principle. So in other words, we need to learn how to do counting, how to count how many different outcomes for a given event before we can do keep statistics, before we can do probability calculation. So let's get started. The title is the fundamental counting principle. This is how we count how many different outcomes of a given event. So let's learn this fundamental counting principle through two examples. This is the first one. It's early morning. You need to select something to wear for your morning class. You have two pairs of jeans. One pair is black, the other one is blue. And three t-shirts, yellow, blue, beige, to choose from. You need to choose one item from each group. That means you need to put on one t-shirt and one pair of jeans. How many different ways you can choose your clothes? First of all, in terms of answer, this is a simple problem. It's not that hard to figure out answer without going to school to learn this fundamental counting principle. So our focus or purpose is not just figure out the answer. More importantly, we want to know how to get this right answer in the general systematic way so that when we have a more complex situations, when we have millions of possible outcomes, we can still get to the right answer fairly quickly. And that's our goal. Again, our goal is not merely get the answer. Okay, now I'm going to draw this so that you can see the answer, correct answer. First, say pretending this is me getting up, okay, in the morning. I need to put on a pair of jeans. I need to put on a t-shirt. It doesn't matter which order you do these two pieces of clothes, right? Like in real life, it's totally personal choice. So I'm going to decide to put on a pair of jeans first. So I have two choices here. Either I could put on the blue ones or black ones, right? There are two choices. Say I just choose to put on blue ones. So this is blue jeans. Let's use straight ribbon jeans. So put on blue jeans. And then after that, I need to make decision what t-shirt I want to put on for today, right? So I have two choices. For example, I just happen to choose the yellow one. So I got a yellow t-shirt. And that's it. I finished this whole task because the whole thing is about to put on two pieces of clothes, right? I finish it. So in other words, if you look at the question, they ask us how many different ways you can choose your clothes. At least this is one way to do it, right? Blue jeans, yellow t-shirt, and that's it, finish it. But if you think about that, after I put on blue jeans, I could have chosen a different t-shirt, right? Say, instead of yellow one, I could have chosen, let's say, a blue one. Now we have two different outcomes now, two pieces of clothes, right? Blue jeans, yellow t-shirt, blue jeans, blue t-shirt. So again, you already guessed that I could have chosen the beige t-shirt instead of blue one and yellow one, right? So I could have chosen this beige t-shirt. Now apparently there are three different outcomes now. Blue jeans, yellow t-shirt, blue jeans, blue t-shirt, blue jeans, beige t-shirt. Now, in the beginning, actually, I could have chosen the black jeans instead of blue one, right? Think about that. So I could have chosen the black jeans in the first place, black jeans. And I can use this black jeans to combine with all of those three t-shirts one by one. So to generate another three possible outcomes. Yellow t-shirt, blue t-shirt, and beige t-shirt. So as a result, I have 6 different ways to put on these clothes. So apparently our final answer is 6. Is 6. And here's the illustration. Right? If I choose the blue jeans, I could choose a yellow T-shirt. I could choose a beige T-shirt. I don't have the exact beige color, by the way. This is supposed to be beige, and the blue T-shirt. Right? That's for blue jeans. If I choose black jeans, I also have 3 different ways to choose a T-shirt. So as a result, you see, this is the final result. We have 6 different outcomes. They're all different from each other. That's how many different ways to put on these 2 clothes. We get the right answer. Again, we get the right answer just by actually lay out these possible ways. Because numbers are small, it's very easy to do it this way. Let's look at the next one. After we finish the second one, we want to develop a more general way to figure out how many different ways to finish a task, such as put on 2 pieces of clothes. Now this is our second one. It is early morning. You need to select something to wear for your morning class. You have 2 pairs of jeans, blue ones and black ones, 3 t-shirts, yellow, blue, beige, and 2 pairs of shoes, black ones and red ones to choose from. So we just have one more item to put on as shoes. You need to choose one item from each group. So that's very clear. You need 1 pair of jeans, 1 t-shirt, and 1 pair of shoes. How many different ways you can choose your clothes and shoes? In other words, this is like a task. My task this morning is that put on a pair of jeans, a t-shirt, and a pair of shoes. That's a whole task. So let's draw that again. So this is me. Woke up and decided to put on the blue jeans first. Then I chose my t-shirt. Again, order doesn't matter which one you put on first. Eventually, the result will be the same. So I chose the yellow t-shirt. So this is the order. Again, order doesn't matter. This is jeans. Then I choose t-shirt. This is just for the teaching purpose, which one I do, which is first, second, and last. And then we choose shoes. So this is my order. So after I put on the yellow t-shirt, I decided to put on black shoes. So black shoes. Let's use a B to represent O. The other one is red. B is okay. Blue shoes. Black shoes, I mean. So this is one way to put on the clothes and the shoes, right? Everybody can see that. Now imagine after I put on blue jeans and yellow shirt, I could have chosen red shoes instead of black one, right? So here, red shoes. Now, this is 2 different ways now because our goal is to put on 2 pieces of clothes and 1 pair of shoes, right? So blue jeans, yellow shirt, and black shoes. Blue jeans, yellow shirt, and red shoes. 2 different ways now. But instead of choosing yellow t-shirt after I put on the blue jeans, I could have chosen another color, right? For example, if I could choose the blue one for t-shirt. Then for this blue jeans, blue t-shirt, I have 2 choices on the shoes, right? So black shoes, this is all. And red shoes. Let's just represent red shoes. That's good enough. Now I have 4 different ways to do that. And I guess most of you can guess next one what I'm going to do. I could have put on the beige shirt instead of these 2 colors, right? So this is a beige shirt. And this one branch out 2 more branches. One is black shoes. One is the red shoes. Now, how many different ways to put on a pair of jeans and a t-shirt and a pair of shoes? 1, 2, 3, 4, 5, 6. That's just for the blue jeans. So in parallel, I could have chosen the black jeans in the first place, right? In the morning. Now, since this blue jeans have 6 automatically, we have 6 different ways to do that. Sure, this one is in parallel, right? We have another 6 ways. So I could choose yellow t-shirt, blue t-shirt, and beige t-shirt. Each one branch out 2 more choices for the shoes. Black shoes, red shoes, black shoes, red shoes, black shoes, red shoes. Another 6 different combinations. So in the end, we have 6 plus 6. We have 12 different ways to put on a pair of jeans, a t-shirt, and a pair of shoes. So final answer is 12. You see, just by having another component being shoes this time, we have way more double this time, different ways to put on them. Now this is the illustration using this picture. You can see this end result. Blue jeans, 3 different ways to choose t-shirt. Each t-shirt branch out 2 more different ways to do the shoes. Eventually, we have 12 different ways to put on these 3 pieces. And they're all different. None of them identical. They're all different. So that's 12 different ways to do it. This is the answer. Now let's summarize after these 2 examples to see how we can find the answer without this drawing. Because in reality, when we have a counting problem in real life, we don't have just a single digit outcome. It's more likely at a minimum several hundred, several thousand, sometimes several hundred millions of different outcomes. There's no way we can draw that. That's why we need to learn how to do counting in the general approach. So now let's go back to our first example. This time, let's focus on this closest piece by piece. So imagine in real life, think about it like real. One way to approach counting and probability problems is treat it like it is really happening in real life, like you actually do it. That way will help you understand situation. So don't focus on numbers, focus on the situation. It's much, much easier. Okay, now let's say this is me. First, I want to focus on the jeans, like as if these t-shirts don't exist. So if I look at jeans, I ask myself how many different ways I can choose a pair of jeans. Apparently, there's only 2 ways because there's only 2 pair of jeans. So there are 2 different ways to put on a pair of jeans. Now, after I put on jeans, it's time to put on t-shirt, right? Now I shift my focus on t-shirts only, forget about jeans. Now, since I have 3 different types of t-shirts, different colors of t-shirts, I have 3 different ways. Since the rule is that we choose 1 t-shirt, 1 pair of jeans. So I have 3 different ways to do that, to do the t-shirts. Now, if we multiply them together, what do we get? We get our final answer, 6 different ways to put on both clothes. And we get the right answer. So in other words, the original problem is how many different ways you can choose your clothes, both clothes, right? The whole thing. So the result, the way we get result is that we can focus on how many different ways to do first piece, how many different ways to do second piece, and then we multiply them together. It happens to be, at least for now, I can say this happens with quotation mark because we are not sure this is always true. It happens to be our answer. 6 pieces, 6 different ways to do the whole thing. In other words, I calculate how many different ways to do each piece and multiply those results together. I got how many different ways to do the whole thing. Now let's look at if we can take the same approach here in the second example. Say, first, I focus on jeans. I have two different ways to put on a pair of jeans because there are two pairs of jeans. And then I focus on just t-shirt. I have three different ways to put on t-shirt because there are three of those. And then I focus on shoes. There are two different ways to do shoes because I only have two pairs of shoes. Now multiply this together, what do we get? We get 12. That's how many different ways to do the whole thing. Put on a pair of jeans, put on t-shirt, put on a pair of shoes. It happens again. That means in order to get how many different ways to do the whole thing, you can break down that whole thing into several steps or several components or several pieces. Then you focus on how many different ways to do each piece. And then multiply your results together. That's how many different ways to do the whole thing. We are right again. Is this always correct? The answer is yes. And this method of calculating how many different ways to do whole thing is called fundamental counting principle. In other words, this fundamental counting principle is pretty much like divide and conquer strategy. In real life, this is a very useful, very powerful. When you have very complex task, you don't want to look at it as a whole one task to do it because you're going to get overwhelmed by the amount of work and time it will take for you to finish that. Maybe you just give up before you even started. Instead, try to break apart a huge task into smaller components, into smaller steps, if that task needs to be carried out step by step, so that you focus on each smaller piece, each smaller step or component, try to figure out how many different ways to do each step, and then multiply together. It will always be equal to how many different ways to do the whole thing. Divide and conquer. And that is called fundamental counting principle. Now we have this definition here. Let's read it. If you can choose one item from a group of m items, let's do a parallel analogy using the first example we did so that you can better understand this principle itself. Say we want to choose one pair of jeans of two pair of jeans, right? So that's the total number of items available. You just choose one out of it. So this is one pair of jeans. And totally we have two pair of jeans to choose from. And the second item, that's our t-shirt. So that's our t-shirt. We need to choose one t-shirt. And the second item from a group of n items. And we have three t-shirts, right? We choose one t-shirt from out of three t-shirts. Then the total number of two item choices, that means how many different ways you can put on the two clothes, right? It's m times n. It's two jeans times three t-shirt. 2 times 3 is 6. We know that's correct, right? So again, you don't have to remember this. The key is understand the information, what they are saying in that principle. Basically, it just said what I just said. It goes like this. If you want to figure out how many different ways to do whole thing, break it down into steps or components, and then try to figure out how many different ways to do each component, then multiply them together. That's how many different ways to do the whole thing. Divide and conquer. Now let's use this fundamental counting principle to do some examples. This is our first example after we learn this fundamental counting principle. The Greasy Spoon restaurant offers 6 appetizers and 14 main courses. In how many ways can a person order a 2-course meal? Now think about like a real life. How do you order a 2-course meal? You tell the people in the restaurant to put the order. Say, I want this appetizer. I want that main course. Right? You do them one by one. It's like 2-step process. So whenever you can break down your task into different steps or different components, That's the indication that you can use a fundamental counting principle. Instead of figuring out the final result, focus on how many different ways to do each component and then multiply them together. That will make things way easier. So in this case, we have 6 appetizers and 14 main courses, right? Focus on appetizer first. How many different ways you can order appetizer? Since you can only order one, right? There's 6 different ones. Sure, you have 6 different ways to do that because you could order any one of 6. They're equally good or equally attractive to you. Well, at least we assume that. So you have 6 different ways to do that. In a very similar way, you have 14 different ways to order one main course because there are 14 different ones. According to the fundamental counting principle, you multiply them together, this is 84. There are 84 different 2-course meals available. You know this is the right answer because we already tested this approach is correct approach, which will give you the correct answer from the first 2 examples. We already know this is true. Now let's do another one. Next semester, you are planning to take 3 courses, Math, English, and Humanities. Based on time blocks and highly recommended professors, there are 8 sections of math. So 8 of this. And 5 sections of English. And 4 sections of humanity. 4 sections that you find suitable. Assuming no scheduling conflict. That means you can select any one of the 8 math sections, any one of the 5 English sections, any one of the 4 humanity sections. How many different 3-course schedules are possible? Apparently, we just need to select one section for math, 1 section of English, 1 section of humanity. That's a 3-course schedule. We want to know how many. Now again, this is like a breakdown into 3 components because your 3-course schedule has to be composed of 1 math section, 1 English section, 1 humanities section, right? We focus on each subject one by one, figure out how many different ways to do that subject, and later on we multiply them together, divide and conquer. Since they are all suitable, no time conflict, you can choose any one out of these 8 sections. So there are 8 different ways to do that. Similarly, this one has 5, this one has 4. Multiply them together. 4 times 5, 20. 20 times 8, 160. You're going to have 160 different schedules available to you. They're all suitable. So that's the final answer. Now we have another example here. After this, we have 2 more exercise problems. Pay attention to this. This one is really interesting. After this, I guess most people won't bother to do any guessing on the test. So let's read it. You are taking a multiple choice test that has 10 questions. Each of the questions has 4 answers, 4 answer choices with 1 correct answer per question. ABCD, just like any typical test. If you select one of these 4 choices for each question and leave nothing blank, that means you have to answer with 1 selection for each question. In how many ways can you answer the questions? So again, this is a typical example. No way can anybody figure out the final answer without using fundamental counting principle because number is big. And you're going to see it very soon. So treat it like a real in real life. It's easier to break it down actually. You have test that has 10 questions on it. And so on. 10 questions. Each question you have 4 choice, right? Multiple choice. Let's call them A, B, C, D. Question 1, you have A, B, C, D. question 2, you have A, B, C, D, and so on. You have 4 choices for each. Now, in real life, when you do a test, no matter which one you start with, doesn't matter. You have to do the test one by one. These test questions. Do the select one for question 1, select one letter for question 2, and until you finish number 10, you finish the test. If you don't finish all of them, you don't call it finish the test, because it's a rule. You have to select an answer for each question and leave nothing blank. Okay, this is exactly the very typical case for fundamental counting principle. Because in order to count how many different ways to do the whole test, you need to figure out how many different ways to do each one, and then multiply them together, break it down, divide, and conquer. Okay, how many different ways to do the first question? Apparently 4, because you could choose any one of the 4, depending on which one you consider to be right. How many different ways to do second one? Again, 4 different ones. So the rest, you see, you have 4 different ways to do each problem. According to the fundamental counting principle, the final answer, how many different ways to do the whole thing, equals all of those ways to do each question multiplied together. So basically, you multiply 4 by 4 by itself 10 times, which is 4 to the power of 10. Now let's use calculator. Nobody can figure out without a calculator. 4 to the power of 10. Let's write down this number. 1,048,576. That's how many possible different answers for this test. And only one out of this many is a perfect answer, is perfect score. So in other words, if you guess, you'll have less than 1 out of 1 million chance to guess all of the problem correctly. Since there are 4 answers, in each question, one of it is correct, so on average, it's 1 out of 4. That means if you know nothing about that test, you just guess them all, your average expected score is 25 out of 100. Yeah, so this one just tells us when you have tests coming, prepare for it and do the homework, understand the concept, and focus on learning, not just luck. That's not going to work. Okay, now let's look at the exercise. We have 2 of this. The first one, a pizza can be ordered with 3 choices of size. You have small size, medium size, or larger size. So in terms of size, this category, we have 3 different choices. That means you have 3 different ways to do that. When you order one single pizza, you cannot order both small, medium, right? 2 different sizes. There's only one of them. So you're going to choose one out of these 3. 4 choices of crust. So just 4 different kind of crust. Whatever they are, just 4 different kinds. Again, you can only choose one because you order one pizza. And 6 different toppings. So toppings, we have 6 of them. Now let's look at the question. How many one topping pizza can be ordered? So just order one pizza with one topping. In other words, the nature of this problem is how many different ways to choose a pizza with one topping. You choose one out of each group because you only need one size, one crust, one topping. So this whole thing order pizza break down into 3 different steps, because when you make order, you need to tell the employee in the pizza restaurant that you want this size, you want this crust, you want this topping, like 3 steps, right? 3-step procedure. There's 3 different ways to finish the first step, 4 different ways to finish the second one, 6 different ways to finish the third one. Multiply them together, there's 72 different one topping pizzas. There's 72 of them. You can order any one of them. That means you have 72 different ways to order a one topping pizza. Okay, one more. That's enough for understanding this fundamental counting principle. The key is being able to identify you have fundamental counting principle problem. Later on, we have other method to do counting for different scenarios. The other 2 methods, one is called permutation, one is called combination. That's why it is critical you identify in what situation, in what scenario, you use which method. And fundamental counting principle is characterized by this task being able to break down into different steps or different components. Okay, let's look at this one. For a temporary job between semesters, you are painting the parking spaces for a new shopping mall with a letter of the alphabet and a single digit from 1 through 9. The first parking space is A1. So they just tell you what your parking space sign look like. First one is a letter followed by a digit. That's one painting. Another one will be another letter, another number. Oh, they're all different so that people can identify where their car is parked, right? I parked Z9, so when I get back from my whatever business, I'm looking for Z9 to find my car, right? So how many spaces can you paint with distinct labels? That means how many different possible labels you could have with these requirements, first one being a letter, second one being a digit from 1 through 9. So understanding the question, understanding the scenario is most important. So if you were that person and you're doing this job, what do? You need to pick letter painted, right? After you finish painting the letter, you pick a number painted. Make sure they're not repeating. There's not repeating paintings, right? So basically, this is two-step procedure to finish painting a parking space sign. Each sign is composed of one letter, one number. When you finish this two, you finish the sign. So the whole task composed of 2 steps. That's why it's fundamental counting principle problem. So first, if I do that, I need paint a letter, and then I need to paint a number here. So first step, how many different ways to do a letter, one number, right? Since we have 26 letters in English alphabet, we assume this English alphabet, and we only need one letter. All of those 26 letters are different. So there's 26 different ways to do this letter. After finish letter, when you choose a number, number can be any number from 1 to 9. That's 9 numbers in between. So times 9. And according to the fundamental counting principle, 234. There are 234 distinct labels in that parking lot so that you can identify your car easily. There are totally 234 different ones. Okay, that's the end of this video. See you guys in the next video.